In this video, we will explain and use the concept of net present value profile and internal rate of return to practice our Python plotting skills while learning finance. Please don't forget to like this video and subscribe to my YouTube channel so I can keep adding more content on Python and finance. I would really appreciate your support. To follow the topics of this video, it is essential that you watch my previous video, Net Present Value with Python. So if you haven't done so, please check the link in the description. Okay, let's do this. First, we set the cash flows from a project starting from the initial cash outlay or the initial investment with a negative sign, followed by the cash flows generated by the project with a life of 5 years from T1 to T5. We save these variables in our Python environment, as well as the discount rate that we're going to be using in order to calculate the net present value. Next, we're going to be saving each one of these variables into a Python list to be able to use them inside a for loop. To set the net present value function, we will use the enumerate function this time. What does the enumerate function do? Let's take a look at it. So if we say enumerate and include the cash flows that we have saved in memory, the only thing that we will be receiving is the location where the information is going to be stored. So we need to force that function in order to display the output by using, for example, the function list. So in this case, we see that we receive a list of tuples that include every single one of the cash flows of the project and an index that corresponds to them. So for example, for the first cash flow 4,000, we have the index 0. For the second cash flow, we have the index 1. For the third cash flow, the index 2, and so on. Okay. So we can use this function in order to set our own user-created function to calculate the net present value. So we're going to be defining it by naming def calc net present value, in this case, NPV, and is going to be taking two parameters, the discount rate on the one hand and the cash flows on the other. We set the net present value equals to 0 in order to start adding the discounted values of every single one of the cash flows. And we say that for I in val, in the enumerate function that includes the cash flows that we defined in the calc NPV function, we want to add them, every single one, and discount them. So we will divide val, every single one of the cash flows, by 1 plus the discount rate raised to the power of I. Finally, we're going to be return the net present value. So the function that we need to use is ready. So let's just take a look. Let's just verify if this is working. So round, calculate the net present value with the discount rate that we set equals to R, or 12%, like in this case, and the cash flows equals to the list of cash flows. So let's take a look at the 3 decimal digits to see if our function works. So it is telling us that the net present value of the project with a discount rate of 12% is going to be equal to $7,674. Okay, good. So let's start plotting the net present value profile. First of all, we need to define the net present value profile. So this is simply a graph showing how a project's net present value changes as the discount rate changes. In this case, we calculate the corresponding net present value of a project with a specific range of discount rates. So we're going to be first of all defining the rates, or the range of rates that we want to use as discount rates by creating an empty list. In addition, we're going to be creating another empty list that will take the all of the net present values, calculating at every single one of the rates that we will be defining now. So we will be using a for loop and saying that for I in a range that will go from 1% to 40%, we want to populate the rate, the empty list called rate, with the following information. So the rate, we're going to be appending 0.01 multiplied by I, meaning by every single one of the values of the range from 1 to 41 in order to get the percentage in decimal points. So we can use them now in order to calculate the net present value. So we're going to be populating now the empty list that is called NPV. So we said NPV append, and we will include the rounded value of the results when we use our function to calculate the net present value that uses a discount rate of 0.01 multiplied by every single one of the values in this range. Okay. So in addition to that, we know that our function takes, in addition to the discount rate, it takes the parameter cash flows that is saved in the list. So we're going to be setting 3 decimal digits. So we run this cell and we have very easily populated the rate list as well as the NPV list. So let's take a look, for example, at the first 15 elements, for example, of the rate variable, and we see that it contains the interest rate 1% in decimal digits from 1% up to 15%. So these are the first 15 elements. We can take a look also at the net present value variable to the first 15 elements, and we can see that it contains the net present values calculated with every single one of the interest rates that we have defined in this variable. Okay. It is a good idea now to convert or to include these two variables into a single data frame. So we can do this by using the pandas data frame, importing pandas as PD, and then defining the data frame called df as PD data frame, and we will include the data in the form of a dictionary. So we will say that the first column is going to be called rate, and as the values, it is going to be including all the values in the variable rate. Okay, so this is going to be the first column. In addition, we will assign a second column that we will call the net present value, and that will take the values included in the NPV variable. Okay, so we said NPV, we run this line of code, and we can inspect the first 23 elements of that data frame. So we see that there are two columns, the column rate and the NPV, of which every single one NPV corresponds to the interest rate that we have used in order to calculate it. So we can verify these by taking a look at the net present value that we have calculated with 12%. So as you can see, this value is exactly the same one as we have calculated at the beginning. Okay. Once that we have our pandas data frame, we are ready to start creating our plot. So we're going to be importing the Matplotlib library .pyplot as PLT, as is convention. And before starting plotting, let's just remember that we can verify that we can filter the net present value that corresponds to the to 12%. So we will see a little bit later why this is going to be useful. So we're going to be saying we're going to be filtering df with log, and we're going to be saying that we want in the column rate the rate that is going to be equal to 12%. So from that row, we want to get the information for the column of the net present value. So if we run this line of code, we will be receiving the net present value that corresponds to a discount rate of 12%, and that is included in index 11. We will see now why this is going to be very useful. So let's start plotting the first of all the net present value profile. So we will be creating, we're going to be using the PLT subplots function. So we're going to be defining two objects, the object fig and the object ax. I will be explaining now what does this mean, but I'm going to be writing first the code. So we can assign a figure size of for that plot that is going to be equal to 7 per 5 inches, for example. And I'm going to be assigning the parameter to the parameter DPI the value of 150. DPI is going to be giving the resolution of the image. So the dots per inch, we know that the higher the dots per inch, the higher the resolution of our image. Okay, so the PLT subplots function creates two different objects, the object fig and the object ax. This is the object figure and the axis. The figure object is a sort of container because it holds everything you see on the space, whereas the axis is the part of the space that holds the data that we want to plot. So that is why we're going to be using the ax in order to plot the net present value profile. What is the definition of the net present value profile? Well, it is the rate that is in the df, the column rate that is included in the df pandas data frame against the net present value. So that is as simple as that. It is the net present value profile. We're going to be setting the z order as 1. I'm going to be explaining what does this mean in a second. So we then are going to be set the color equals to red and a label that explains or that defines what this line is going to be referring to. And as we have said, this is going to be the net present value profile. Okay, so we're going to be setting the x labels of that plot with the function set, for example, first x label. And this is going to be the rate. In addition, we can set the y label. That is going to be the net present value. It is as simple as that. So in order for these for this image, for this plot to be displayed, we want to make sure that the labels are going to be correctly shown by using the PLT legend. And if you're using, for example, a .py script, you say, in order for the image to be displayed, the PLT show command. So let's take a look at what this is returning. This is returning the net present value profile. This is the line that plots the rate against the net present value. Okay, so what can we do next? So next we can say we can plot the line a point. Let's plot the point that corresponds to the net present value calculated with a 12% discount rate. So the rate is going to be on the x-axis and the net present value on the y-axis. So in this case, we are going to be using, to make the things easier, because we are going to be plotting a point, we can use the scatter type of Matplotlib. So we're going to be saying scatter, and we're going to be defining the x-axis and the y-axis. In the x-axis, we want to include the rate that is saved in the variable r, and that is equal to 12%. In addition, we are going to be plotting the next coordinate, the y coordinate is going to be given by the net present value. So we can copy this value as is, but we know that this is obtained with this line of code. So let's just copy this line of code to plot the second coordinate that we need in order to plot that point in our plot. We need to define, for example, the marker, or what is going to be the marker. It's going to be a dot with an O, with just with the letter O. We can say that we want it to have a color blue, that the size is going to be 75. The Z order is going to be the second one. I'm going to be explaining in a second what this means. Then the label, and the label is going to be it's going to be called the cost of capital. Okay, so the cost of capital, as we know, is R, and in this case is going to be 12%, which corresponds to a net present value equals to this number. Okay, so let's run this line of code. Hopefully we haven't made any mistakes, and it is not the case. So in this case, you see that on the one hand you have the net present value profile, and on the other hand you have the dot that corresponds to the net present value calculated with the cost of capital equals to 12%. So why am I using then this Z order? So assume that I am not plotting or using this parameter. Let's get rid of the parameter Z order, and let's see what the result is. So let's run this line of code, and as we see, the dot is behind the line. So we want the line to be displayed first, and then above the line we want to plot the cost of capital. That is why we are adding the Z order parameter. Okay, so the Z order parameter, first of all, let's put it in here, Z order. If we assign the value 1, that means that the first thing that we want to plot is going to be the net present value profile, or the line. So that is the order 1, the Z order equals to 1. If we set on the point corresponding to the net present value with an interest rate of 12%, the Z order equals to 2, then in this case, what this is going to be doing is that it is going to be plotting, first of all, the line corresponding to the NPV profile, and secondly, above that line, it is going to be plotting the dot, the point corresponding to that specific net present value. Okay, so that is the use of the Z order parameter. Okay, so next we can show a horizontal line that is going to be dividing the graph into positive net present value and the negative present value. So in order to do so, we are going to be defining two variables in one single line of code. We're going to be defining the coordinates. The variables are x and y, and the values that corresponds to x, let's set it to 0 and 0.40. So this tuple is going to be equals to x. So then we are going to be defining the value of y, which is going to be equals to 0, 0. What is this? So in this case, the first 0 that corresponds to the variable x is going to be x1, and 0.40 is going to be x2, while the first 0 of the variable y is going to be y1, and the second 0 is going to be equals to y2. So we have defined these two variables, and this time we want to plot a line. So that is why we'll use the plot function of Matplotlib. So we are going to be plotting this X and Y line. So let's run this line of code, and we see that we have a line that goes from this point to this one set by these coordinates, and that corresponds to a net present value exactly equals to 0. Okay. So these are the basics of plotting. Suppose that we wanted to add some other elements to these plots. So we are going to be adding the internal rate of return. What is the internal rate of return? Well, it is just the discount rate that makes the net present value of the project equal to 0. In other words, the internal rate of return can be defined as a discount rate that equates the present value of the project's cash flows with the project initial cash outlay or initial investment, such as in this equation. So put it simply, the internal rate of return attempts to answer the question, what rate of return does this project earn? Okay. So as you can imagine now, what we need to calculate is the internal rate of return. To do so, we're going to be importing the NumPy financial library as NPF, and then we're going to be calling from that library, we're going to be calling the function internal rate of return that take only one argument, which are the cash flows. If we run this line of code, then we can verify that the discount rate that makes the net present value of the project equals to 0 is going to be approximately 19.94%. Okay, so this is the net present part of the internal rate of return. Okay, how can we demonstrate that this is the case, that the net present value, when we use it as the discount rate in this formula, is going to be returning a net present value equals to 0? Well, we can use the function that we have defined as calculate net present value, and as the discount rate we're going to be including the internal rate of return. This is the discount rate with the cash flows that we defined, and the second element are going to be the cash flow, the second parameter. So what is the net present value that this is going to be returning? Well, as we can see, it is in scientific notation, but this is extremely close to 0. Okay, we can round, for example, to use the normal notation that we are all used to. We can round, for example, this number with a round function up to 5 digits or 10, whichever you like, because in any case this is not going to be returned. This is going to be returning only the first one, given that all of the other 5 are zeros. In addition, we can also use a formatted string literal, or the F string, with a replacement field denoted by curly brackets, in order to again transform the scientific notation into the classic display of numbers. So in order to use the F string, we set the F open quotes, and inside the curly brackets, this is going to be the replacement field. We're going to be including the information that we want to be formatted as we want. So the information is going to be the function net present value that includes the internal rate of return as the discount rate with the cash flows that we have defined, and the cash flows as the second argument. Okay, so once that we have defined the number that we want to format, we need to specify the exact format that we want. Supposing that we want to display from the scientific notation, we want to display only the 15 decimal digits. So we're going to be saying that we're going to be saying 0.15 F, and this is going to be returning the number, this number in scientific notation the classic notation, but with 15 digits, and we can verify that this is practically 0. So we can confirm that this internal rate of return equals to approximately 19.94% is the discount rate that equates the net present value to 0. Okay, good. So this is what we need in order to plot the internal rate of return. This is the information that we need. So in order to plot it, it is going to be very, very easy. Let's just copy the code that we have defined, because the only thing that we need to do is to add just a few lines of code. So let's make some space in this case to include the lines of code that we need, which correspond to the point or the intersection between the net present value line and the horizontal line that represents the net present value equals to 0. So this intersection is going to be the internal rate of return. So as we can see just visually, it is going to be around 20%, which is the number approximately that the function internal rate of return returned. Okay, good. So because we said that the internal rate of return is going to be a point, it is very easy to plot it by using the scatter function of Matplotlib. That is going to be taking as the x-axis the internal rate of return with the cash flows that we set. This is the first axis. And in the y-axis, we're going to be setting it to 0, because remember that we want it to be exactly in this line. Okay, good. What is next? What do we do next? Then we set a marker. For example, say that we want the marker to be equal to a star. We set it as an asterisk, and this is going to be marker, not marker. Marker equals to a star. We set the color equals to black, just for example. The size equals to 175. The Z order is going to be logically 3. And we're going to be assigning a label by practicing using the F string. So the F string is going to be taking is going to be set by opening quotes. So we're going to be saying that this is the internal rate of return. So this is text, and this is going to be equal to what? It is going to be equal to a number that we want to replace in the space that is given by the curly brackets. So in that space, what do we want to do? We want the rounded value of the internal rate of return. So NPF IRR with the argument cash flows and rounded to, for example, 5 digits. To 5 digits, okay? So in addition, we're going to be specifying again as text. This is the only, inside the curly brackets is the numerical information that we need to add or that we want to replace. And we can continue with text by specifying that this corresponds to a net present value equals to 0. Okay. So let's check if we haven't made any mistake. And apparently, the only thing that to know that is by running this code. Okay, so this is not matching the parentheses. What is the mistake? So cash flows 5. So in this case, the round, we are missing here a parenthesis. In this case, the closing brackets, closing parentheses. Now that we have added, we have exactly what we wanted. Okay, so this star is exactly the internal rate of return that corresponds to a discount rate of 19.94, and the net present value equals to 0. Okay, so this is the way that we plot the net present value profile as well as the internal rate of return by using Matplotlib in Python. So what we can conclude over all of this, over this exercise is that the accept-reject criterion of the internal rate of return method is going to be the following. If the internal rate of return is greater than or equal to the firm's required rate of return or cost of capital, we need to accept that project because in this case the net present value is positive. If the internal rate of return is lower than the firm's required rate of return or cost of capital, we reject it because in this case the net present value is negative. Okay? Good. So I hope this was useful. Thank you for watching this video and hope to see you on the next one. Thank you very much.